So I'm going to extend on what you learned in your prior course on solving linear equations. So I'm going to give you a set of 5 steps that we are going to take for every single linear equation that we're solving, no matter how difficult or how simple it may seem. And now at times we're going to get to skip steps, but we will always go through these. So step 1, I'm going to get rid of parentheses. I'm going to distribute. Step 2, I'm going to combine like terms on each side. When I say each side, I mean each side of the equal sign. We're always going to split the equation in half by the equal sign. I'm going to make sure I have a variable on only one side by adding or subtracting extra variables to both sides. I'll get rid of addition or subtraction by getting rid of anything not attached to the variable, and then I'll get rid of anything attached to the variable through multiplication or division. I can, just a little side note, and you'll see how this works. I have it in an example. But I will get rid of fractions that are attached, in other words, multiplying by a variable, by multiplying by the reciprocal. Sorry, no. So if I look at example 1, I'm going to go through this exact same process that I just mentioned up above. Okay, sorry about my dog. I chased a rabbit out of the front yard, so hopefully she'll calm down now. I'm going to go ahead, and as I said in example 1, I'm going to follow these steps. First thing I'm going to do is, if there are parentheses, I'm going to distribute. Since there are parentheses, I'm going to distribute the 2 in. Remember, when I distribute, I use multiplication. 2 times c is 2c. 2 times minus 6 is minus 12, equals 1, plus 9c plus 1. Next thing I'm going to do, I'm going to combine like terms on each side. So again, my sides are my sides of the equal sign. So I'm going to draw a line to split that, to represent my 2 sides. Looking on the left, 2c and minus 12 are not like terms, since 2 has the c and 12 does not. On my right, 9c doesn't have any like terms, but I can combine the 2 ones. Since they're on the same side, I just put them together, giving me 2c minus 12. 1 and 1 come together to be 2 plus 9c. Step 3 then tells me to make sure I have a letter or a variable on only one side. Well, I have a c on the left and on the right, so I have to get rid of one of those through addition, and subtraction. So I'm going to go ahead and get rid of this 2c. I usually like to get rid of the smaller one because it means I'm less likely to deal with negative numbers. So I'm going to get rid of it by subtracting it. I always have to do the same thing to both sides. And now 2c and 2c subtract to be nothing. Negative 12. My equal sign drops down. My 2 drops down. And 9c subtract 2c leaves me with a positive 7c. Now I have a 2-step equation like you've seen before. So I'll get rid of anything not attached to the variable. So I'm going to go ahead and get rid of this 2 through subtraction. I do it to both sides. Negative 12 minus 2 is negative 14. Again, my equal sign drops down, and I'm left with a 7c on my right. And the last thing I need to do is then, that's step 5. I'll get rid of anything that's attached to the variable through multiplication or division. Since it's 7 times c, I'll use division to undo a multiplication. And negative 14 over 7 is the same thing as negative 14 divided by 7, which I know gives me negative 2 for my c. And the goal of solving is to get the variable by itself, so I have successfully done that. Moving on to example 2, working through the same process. Before I start it, I'm going to rewrite it because the program that I use to make these doesn't do fractions very nicely. So this is 2 plus 2/3 m minus 7 equals 3m. So that's what this problem is saying. So first thing I'm going to do is I'm going to get rid of parentheses by distributing. But notice I don't have any parentheses, so I can skip step 1. I'm going to go ahead and draw my 2 sides in. And the next thing I'm going to do is I'm going to combine like terms on each side. Well, on the left side of the equal sign, I have a 2 and a negative 7. So they come together to be negative 5. I don't have any other m terms, so the 2/3 m drops down. I don't have any like terms on the right, so I keep it a 3m. From here, I need to make sure I have the variable on only one side. Well, I have the variable on both sides, so I'm going to subtract one of those away. I'm going to subtract the 2/3 m away. Doing that, so minus 2/3 m from both sides, I see I'm going to have to use my fraction rules. So I'm going to go ahead and say I'm left with a -5 on the left, and on the right, I have -2/3 subtracting from 3m. Well, to subtract fractions, I need a common denominator. So I'm going to go ahead and say 3/1. So 3 and 1, their least common denominator is 3. So I'm going to multiply top and bottom here by 3 to gain that common denominator, giving me 9/3 m minus 2/3 m. Going through with the subtraction, I have 7/3m. So now I'm going to draw the attention to this piece here. If I have fractions attached, now you put attached in quotation marks because it's when their fractions are multiplying by a variable, I'm going to multiply by the reciprocal. So I'm going to multiply by 3/7 to get rid of them. I'm going to do that because using that reduce first method, my 3's and my 7's reduce and I will have just m. I have to do the same thing to the other side, so I'm going to multiply this side by 3/7 as well, giving me a final answer of -15/7 equals m. And again, my goal of solving is to get the variable by itself, so notice the variable's alone on one side, so I have reached that goal. Looking at one more example together, example 3, this would be, oh, I'm sorry, there's two more. There's an application problem for example 4. Example 3 would be a good one for you to pause the video and try. Now that you've had a chance to try one, let's walk through it together. I understand that I cannot see my steps anymore, but they should be on your notes still. So the first thing I'm going to do is get rid of parentheses by distributing. So I'm going to distribute this minus sign in. I'm also going to distribute a plus 3 in, giving me 3x minus 2 minus x equals, the 5 drops down, positive 3x, negative 12 after distributing. I'm going to go ahead and say these are my two sides, and my next step tells me to combine like terms on each side. Well, on the left, I have a 3x minus x, which gives me a 2x. My minus 2 drops down. On the right, I have a 5 minus 12, giving me a negative 7, plus 3x drops down. I have to make sure and draw my equal sign in. And now I want to make sure the variable's on only one side, which means I either have to subtract the 2x away or subtract the 3x away. It doesn't matter which. Again, I like to get rid of the smaller number, but it really doesn't matter. And now I have negative 2, my equal sign drops down, negative 7, 3 minus 2 is a positive 1x. I now get rid of that minus 7 since it's not attached to the variable by adding 7 to both sides. One thing I want to point out on that, it doesn't matter that it's plus behind it because it's the sign in front of the number that determines whether it's positive or negative. Negative 2 plus 7 is 5. The 7's cancel and I'm left with 5 equals 1x. Well, since 1x is the same thing as just 1 times x or x, I've reached my goal of getting the variable by itself. The final example, example 4, is an application problem. This picture here is a picture of what we call vertical angles. Okay, they're coming to a point together. What you learn in geometry, not geography, is that vertical angles are always equal to one another. So in this situation, the first thing I'm going to do is I'm going to say, hey, I understand that based on this picture, 6x plus 3 is equal to 8x minus 21. That's not a very good color. I'm going to switch back to red. And I'm going to go through my steps. Since there are not parentheses, I can skip step 1. There isn't anything to distribute. I look at both sides. I do not have like terms on the left. I do not have like terms on the right, so I can skip step 2. Step 3 says make sure a variable is on only one side. Well, I have a variable on the left and the right. So I'm going to go ahead and get rid of one of those. I'm going to get rid of the 6x by subtracting that chunk away. And I get 3 equals 2x minus 21. Now I'm ready to use addition or subtraction to get rid of anything that's not attached to the variable. So to get rid of the 21, 3 plus 21 gives me 24 equals 2x. I have one step remaining. I have to get rid of that 2 by dividing. Those cancel, and I get x equals 24 over 2, which I know is just 12. And again, I've reached my goal of getting my variable by itself. So make sure that you are reviewing these steps. You will be responsible for learning this process and being able to complete the steps and go through the steps on each problem. Please make sure you bring any questions you have with you to class, and we can discuss those together one-on-one.